Okay, we're gonna have to simplify these equations, these expressions, trig equations. We're gonna have to simplify it, and I've drawn my Cartesian plane. As I told you, I like to work with the Cartesian plane so that I can have a specific positions of the angle in the Cartesian plane. So I have to simplify these expressions. So when you be asked to simplify these expressions, so you must move on to step by step. We're going to start with this first one, sin 90 plus theta. 90 plus theta we know in quadrant 2. So in quadrant 2, we know that sin it's a positive because this represents the sin as a positive, as I like to draw, and this represent the cos. So we know sin as a positive. We know, as I explained from my previous video. So if you hasn't looked at my previous video, you have to subscribe so that you can have access to all my video. So sin 90 plus theta we know is a cofunctions, which is going to give you a cos theta. But the sign of the sin in this quadrant is a positive, therefore there's we're going to have cos x. Now we move on to tan. Tan 360 plus theta, we in quadrant 1. So tan in quadrant 1 as a positive, because positive times a positive, positive divided by positive is going to give you positive. So tan 360, as we say, is a function. So it's going to remain tan x. Now we're going to move down into the denominator. 180 plus x, 180 plus this, we're going to come here in this quadrant. We know it's a function, which is going to give us sin x, but in this quadrant sin is a negative here, so therefore we can have sin x times 90 minus theta. 90 minus theta we know already we in quadrant 1, so we know in quadrant 1 that cos here it's a positive, therefore we can have a time sin x. Now we have an angle which is 540. So you mustn't scared when you see a big angle, because you remember we say our angle goes in the Cartesian plane from 0 to 360 degree, from 0 to 360 degree. But remember also we say it depends on the number of the toe of the Cartesian plane. The more you go, the number of the toe of Cartesian plane, so you plus 360 degree all the time. But in order for you to do the reduction formula, what you have to do, you just need to find the corresponding angle of 540 from the first toe of Cartesian plane. So what you have to do, you're just gonna do 540 minus 360. Minus 360. So 540 minus 360 is gonna give you 180. So 180 is a corresponding angle of 440, because you just reduce this angle. Because if you type sin 180 and sin 440, you get the same answer. So here we're gonna reduce them as a 180. Therefore, cos 180 plus theta, we come in this quadrant. Cos is a negative 180. You can see in quadrant 3. So therefore, this is gonna be plus. Sorry, it's my pen, cos 180. Let me just write it properly. I'm gonna write it. My pen is a bit slow because of technology. So sin x plus cos 180 in this quadrant is a negative, because it's a negative, therefore this sign is going to turn into a negative cos x. Okay, and we have also cos negative x. Cos of negative x is giving you cos x, so this is going to be times cos x. I'll explain you at the end of the sessions why cos negative x give you a cos x. So now into the denominator we have don't forget the sign here, it's a multiplications, and the sign here also it's a multiplication, but the sign in here it's a subtraction. So we have cos x times cos x this side, and we have sin x times sin x this side. Don't forget what we have in the numerator. So in the numerator we're gonna write cos x. Remember, tan we can express this as a sin x over cos x into the numerator over negative sin is going to give us a negative sin squared. It's going to give us to write it properly, it's going to give us negative sin squared x, okay, minus cos squared x. So once we simplify the cos, we're going to remain with the sin. So we're going to have to move to our next pages. So remember, we have a sin over negative sin square x minus cos square x. So let's move on to our next pages. Don't forget what you see in your previous pages. We're going to move on to the next pages. We carry on with our exercises. Don't forget that we have sin x in the numerator, as in the denominator we have a negative sin square x minus cos squared x. Okay, let's move on to our next pages. Laptop, move fast. Give us a second. It's loading. Yes, we have our next page. So remember, in our next pages we had 6 from our previous pages. We have sin x over negative sin squared x minus cos, I'm going to try to write slowly, cos x. So we know that in the denominators that sin squared plus cos squared give us 1. So we know that from the quotients of identity, sin squared x plus cos squared x is going to give us a 1 from the quotients of identity. Don't forget that. So what we have to do, we have to put a negative sign as a common factor. So this we can write this as a sin x over, put a negative sign over the bracket, so that we have a sin squared x plus cos squared x, we close the bracket, and then from this we know that this is going to give us 1. So therefore our answer is going to be sin x over minus 1. So therefore this is the same as a negative sin x. So we have simplified our expressions. So the final answer is a sin x. Remember, I said that I will explain you why cos of negative x is equal to the cos of x. I'm going to draw this Cartesian plan, but this one, it's a negative Cartesian plan. The negative Cartesian plan is open in the directions of clockwise, but the positive Cartesian plan open anti-clockwise. So here we're going to have a negative theta. Negative theta is the same as a negative x. So we know that the quadrant doesn't change. This is quadrant 1, quadrant 2, and quadrant 3, and then we have a quadrant 4. So in quadrant 4, as I say, everything remains the same, just the opening. The sign here is a negative because this is a sin. Here the signs are positive, here the sign are negative. But remember, here is the first quadrant where we have a negative x. So in this quadrant, we know that negative x cos here in this quadrant is a positive. Therefore, the sign here is equal to cos x because cos in this quadrant being a positive here. Okay, as I say, explain. So you have to know that cos of negative x is positive, cos of negative x is a positive cos x, but negative, let me say the sin of negative x, it will be equals to negative sin x. You know why? Because of sin into this quadrant as a sin row here being a negative, That's why I say it's going to be a negative. So if you have any other questions, you can just write it in the comment or email it to me. My email address is down there. It's simonkazadi44@gmail.com. It's also written down here, so you can write it in the comment. I'm gonna read the comment or subscribe so that you can have all my video. And if you have questions or if you have a subject that you want me to explain or a topic that you want me to explain, you say, well, we have functions, you have exponential functions, because there are a lot of topics from grade 10 to 12. So just talk to me or write it on the comment, then I will explain it for you. Okay, thank you.